All right, if you watched the first video or if you're in class, you may be wondering, okay, that's all great, but what the heck does that have to do with this quadratic that we originally started with? Why in the world? We've been talking about these problems that aren't quadratics, that don't look anything like the problem that we saw in the original. What's the connection? Well, if I take that example and I say x squared minus 3x minus 18 equals 0, I'm just gonna kind of play around with this. Okay, inverses won't work. So this new rule says I can solve it if it equals 0. Well, that is true. And I almost just knocked my phone tower over. That's terrible. And then the second thing is if it is the multiplication of two factors. Okay, so I have a problem here. This is not the multiplication of two factors. However, we just spent like 30 weeks learning how to break this problem into two factors. Remember, there's 3 categories for factoring. It may be a GCF problem. It may be a trinomial problem. And remember, trinomials actually have 2 different categories. You have the simple trinomials, where there's kind of a little shortcut, and then you have the complicated ones where you have to actually like set up the box and do all the math there. Or a little bit more rare than the other is where you have the difference of squares. Okay, so I'm going to look at this problem and I'm going to say, hey, wait, that's something I know how to factor. That is a simple trinomial. Well, the trick with simple trinomials is I can skip straight to the factors of x and x. Okay, I'm not going to change the equals 0 part. All I'm doing is rewriting this as its 2 factors like we've been doing. So remember my rule, they need to add to make the middle number, multiply to make the back number. Pause it if you need to. You get x minus 6 and x plus 3. Those are the factors. You have not actually solved this problem yet. You've just broken that trinomial into 2 simpler factor pieces. So rather than trying to tackle this big nasty expression, we now have 2 easier expressions being multiplied together. And the first set of notes really focused on, okay, so how does this work? Well, if I have 2 things that are multiplied together that equal 0, then either this one has to equal 0, so x would have to be 6 for that one to become a 0, or the back one has to be a 0. So if I have a negative 3, that's going to make the back one become a 0. Not too bad, right? It's just kind of putting together everything that we've been doing. So when inverses won't work to solve it, try breaking it into simpler factors and see if, hey, now it equals 0. This is a much easier process. Okay, so if I give you, sorry, I'm looking at my next example. It's not making sense to me. I didn't think that's what I did. 3x squared minus 5x equals 0. It equals 0. So that part is okay. It needs to be factored. It's not a multiplication of factors, so I need to factor it, and the category I'm going to use to factor this one is a GCF. I'm going to look for the greatest common factor. So really the only thing these 2 have in common is an x. I'm going to take an x out front. That's going to leave a 3x minus 5. Okay, go back and look at the notes on greatest common factor if that's a little bit iffy for you. It still equals 0. So there I've done just the factoring step. Now I've got a multiplication problem. I have this factor times this factor that equals 0. So in order for it to multiply and equal 0, one of these pieces has to be a 0. Well, the first one's pretty simple, actually. Okay, so x has to just straight up be 0. If x is a 0, then when I plug it back in, 3 times 0 squared minus 5 times 0, it all becomes 0. The other option, it comes from this back factor, and so we just kind of learned the shortcut for x would be Remember the opposite sign, so it's going to be a positive. You don't have to write positive. 5 is the numerator over the coefficient, which is 3, so positive 5/3. If you go back in like a calculator and actually plug in positive 5/3 and do 3 times 5/3 squared minus 5 times 5/3, you will find that it equals 0. I don't have a calculator on me, so I can't prove that to you, but you can do that on your own if you want. All right, how about 6x squared? Where am I? 6x squared plus x minus 1 equals 0. It equals 0, but it is going to have to be factored. And when I factor this one is a complicated trinomial. It follows that trinomial pattern, but it is a complicated trinomial. So when that happens, I'm just going to come out here to the side, use some scratch area to set up my box. The first term goes in the first box. The last term goes in the last box. And then I'm going to say, okay, I need two numbers that add together to make positive 1 and multiply together to make negative 6. Remember, on the complicated ones, you have to do the front times the back. So pause it if you need to, but the answer, or not the answers actually, 3x and negative 2x. Now remember, factoring, we've done this, so we look for the greatest common factor. That would be 2x and 1, 3x and negative 1. That would be a positive 1 and a negative 1. So the factors are 2x plus 1 times 3x minus 1 has to equal 0, which means that I end up with, okay, so x is the opposite sign, 1 over 2, negative 1 over 2, or the opposite sign, 1 over 3, so positive 1/3. So it's just, again, the whole concept of you are breaking apart a complicated problem into two simpler problems and then going from there. The last category that you may see, oh no, wait, I lied to you. I'm going to do two more examples. Let's say I have 49x squared equals 9. This one throws kind of an additional problem because to start out, it doesn't equal 0. So you have to make it equal 0, okay? So how do I get this to be a 0 instead of a 9? I'm going to subtract 9 from both sides. So I end up with 49x squared minus 9. If you were thinking that this should turn into a 40, it's because you were thinking they're like terms. They are not like terms. Please don't treat them like terms, okay? So now I have the problem equaling 0. So we're good on that criteria. And I'm going to factor it. Some people in class wanted to solve this with square roots. You actually can on this problem, but I kind of want to show you the factoring. There is no greatest common factor. It's not a trinomial. It doesn't have the 3 pieces. It is, however, the difference of a perfect square and a perfect square. So this is actually a difference of squares question or problem. So remember, difference of squares problems break into the plus factor and the minus factor. And so you say, okay, well, that's going to be 7x and 7x to get 49x squared. And 3 and negative 3 will give me the negative 9. So my solutions are change the sign over 7, so negative 3 over 7, or change the sign 3 over 7, positive 3 over 7. And if I wanted to get really fancy on this, I could say, oh, so it's really positive negative 3 over 7. So remember that way of writing the answer that we've seen before. Okay, one more. 6x squared minus 5 equals negative 7x. It does not equal 0, so I'm going to add 7x so that it equals 0. And this is where your little brain's liking patterns is a good thing, because you're probably going to want to put this in the right location automatically. It goes in the middle. So I'm going to write 6x squared plus 7x minus 5 now equals 0 because those have canceled out. And now I can factor it as a trinomial, a difficult trinomial. So I'm going to set up my box off to the side. I'm going to factor this fairly quickly. 6x squared minus 5. I need numbers that add to make 7 and multiply to make negative 30, which are positive 10x and negative 3x. Okay, I get positive 7 and negative 30. And then factoring 3x minus 5, plus 5, because I'm actually going to put my negative there, negative 1, and 2x. So I get factors 3x plus 5 times 2x minus 1 equals 0. Factoring is not new at all. The solving part, our little shortcut is, okay, the opposite sign, 5 over 3. The opposite sign, positive 1 over 2. And again, take a calculator, plug in 1/2 up here. See if you actually punch in 6 times 1/2 squared minus 5 and see if it equals negative 7 times 1/2. Okay, it should totally work.